Hello everyone, welcome back to tutorials on O-level mathematics with me again, your presenter Said Piri. So today we're going to talk about functions, and in this tutorial video we're going to look at the definition of functions. We're going to look at the definition of range, domain, the input and output variables. We're also going to look at the notation. Also going to look at the inverse functions as well as composite functions together with examples. So what is a function? The definition there on the board states that the mathematical relationship between two variables where every input variable has an output variable. So let's take for example y is equal to 2x plus 3. Here our relationship in this equation that has been given is actually telling us that between these two input variables, variables x and y, the relationship is that we have to multiply 2 to x and add 3. So one of these between x and y, one of them is an input variable and the other one is an output variable. What is an input variable? An input variable is that variable that we can choose at random. It's actually an independent variable. You can just choose it freely. For example, I might decide in this relationship that my x value there should be 3. I've chosen 3 at random. However, y is an output variable or a dependent variable. A dependent variable, why? Because it will depend on the value of y that we're going to choose there. It will depend on the value of y that we're going to choose there. So it will depend on the value of x that we're going to choose there. Since we have chosen x to be 3, we will put 3 there. We're going to have 2 multiplied by 3 plus 3 there. You're going to have 9 there. So what we're trying to say here is that the value of x will determine the value of y. So I would say, when you're using, as we're going to see under notations, we're going to say this one is going to be that. If we choose 4 here, we're going to have 11 there. If we choose 5, we're going to have 13 there. So as you can see from the definition here, this qualifies to be a function because we say a mathematical relationship between two variables. What are those variables here? The input variable or the dependent variable x, and the output variable or x is the independent variable while the y, the output variable or the dependent variable. So this relationship that they have is multiplying 2 to x and adding 3 there. So they are saying every input variable, which is the independent variable, in this case x, has an output variable, in this case y. There's only one output variable for each input variable. So there's this input variable, one for each input, one output. One input, one output. That's what a function is. Okay, now that we've talked about the definition of a function, we need to talk about the definition of the range as well as the domain. So the domain is actually set of input variables. A set of input variables is what your domain is. I want to explain what that is. Then your range is set of output variables. Now, remember I said, suppose we take y is equal to 2x plus 3. Suppose we take y is equal to 2x plus 3, and I said that when we take x to be 3, you have y to be 9. When you take x to be 4, you have y to be 11. When you take x to be 5, you have y to be 13. Now we said these values that are here are actually for x. X in this case is our input variable or our independent variable. It's our independent variable. Independent variable. Why is it our independent variable? We said its values can be chosen at random freely. The way I was doing, I just chose to start from 3 and end to 5. But these values that are here, the ones for y, they are output variables or our dependent variable. Why dependent? Because they actually depended on the values of x that we chose at random there. Now, the set of these input variables, we can say x is greater than 3, greater or equal to 3. That's why we're starting from. We're starting from 3 going up. So this set here is what is known as the domain. This set here is what is known as the domain because we have values of x that are starting from 3 and we're going beyond 3. That's our domain, a set of input variables. Then here, the y is greater or equal to 9. All the values that we're going to get, when we get values that are equal or greater to 3 and put them in that relationship there, is going to give us these output variables that are equal or greater to 9. So this set here that we are having is actually our range. That's what our range is. All values that are greater or equal to. Okay, so we have talked about the function, definition, the range, domain, as well as input and output variable. Now we're going to talk about notation. What is notation? Simply the way of expressing functions or how they are written down, At the beginning, I said, suppose we have y is equal to 2x plus 3. Suppose we have y is equal to 2x plus 3. We should take note that y is equal to f of x. We can say that y is the same as y is equal to f of x. That's what we should take note of before we start writing down functions. We should know that y is equal to f of x. So this means that we can actually substitute y for f of x. This means that y is equal to 2x plus 3 can be written down as f of x is equal to 2x plus 3. So this f of x is actually a way in which functions can be written down or they can be shown. When this f of x is read as f of x, this thing that is f open bracket x is read as f of x. So that's how you can actually write down functions. F of x is equal to 2x plus 3. However, you might also realize that there's also another way. As you're doing your studies, you can also find functions written as follows. F such that x maps into 2x plus 3. So, whether written as y is equal to 2x plus 3, this is still a function. The first one is replace f of x with y. Whereas f of x in here, we replace it with y, as we will see in the examples. Number 2, make x the subject of the formula. Number 3, exchange positions of x and y. Then the final step is replace y for f of x, of f of negative 1x. While there is y in the, after we have done all the steps, while there is y, we're going to replace it and put f negative 1 of x to show that we have now arrived at an inverse function. We have now converted the function into an inverse. Now we had 3 mapping onto 9, 4, 11, and so on. So this function here is mapping x onto y, on x variables onto y variables. Now, an inverse function is a function that reverses this mapping. It reverses. Inverse function written as f of negative 1 of f negative 1 of x. F negative 1 of x is showing that this function is an inverse function. It reverses the mapping. It gets to map y onto x. It gets to map y onto x. So now when you have been given a question, how do you come up with an inverse function? There are actually 3 steps that you would require, that you have to follow when you're writing down a function. When you're changing a function into an inverse. Okay, so now we are done with inverse function. Let's look at it. So a composite function is gotten when an output of one function, say g of x is equal to 3x, is used as an input of another function. Say f of x is equal to 2x. So the way we had gotten values at the beginning, like 3, 4, 5 for the input, and for the output we had gotten 9, 11, 15. That was for the function f of x is equal to 2x plus 3. Now suppose we get another function, say g of x is equal to 2x. When we use the output of this function to be the input for that function, then the function that we are going to get, the function that is going to come out will be a composite function. It is really written as, for example, from there we have g of x is equal to 3x and f of x is equal to 2x. If we use the output for g of x as the input for f of x, it is written as g of f of x. When you see something like that in your question, just know that the examiner wants you to find a composite function. I want you to find a composite function. You can also find it written as g open bracket f open bracket of x, like that. That's what a composite function is. Sometimes they can say g negative 1 of f of x. It means you need to first find the inverse of this and use it to come up with a composite function, as we're going to see in the coming examples. So the composite function, you're using an output of one function as an input for the other function. The resulting function that you're coming up with is the composite function. Okay, now that we have looked at how to find the inverse function and the composite function, so you should keep in mind that the inverse function is actually concept 1, whilst the composite function is actually concept 2 of this video. Now we're going to look at exam questions, and our first example is saying the functions f and g are defined by f of x is equal to x minus 3 over 4 and g of x is equal to 2x plus 1. Find a f of 2, b f inverse of x, c f g of x, f of g of x, and d f of g of negative 3. So I'm going to start with a here, f of 2. Now, the way you should think about this, or the way this, or what this means, is that when you have a function and they have replaced a variable there or the letter there with a number, it simply means the variable that was there or the letter that was there is x is equal to, it simply means x is equal to 2, because that's where x is here. They have put 2 there, so x is equal to 2. And which function are you getting here? Is it the g of x is equal to x plus 1 or f of x is equal to x minus 3 over 4? It's this function that you are using because of the name of the function that they have put there. They have put f there, so we're actually getting the function there, f of x is equal to x minus 3 over 4. So what this is trying to say is that by just replacing x with 2, so we have f of 2 is going to be 2 minus 3 over 4. So f2 is equal to 2 minus 3, that's negative 1 over 4. So that's negative quarter. That's how you solve that particular type of equation. When you have the function, the name of the function with a number in brackets there, read as f of 2, it simply means x is equal to 2. It simply means. Okay, so that's how you go about question A. So we are done with this. We now go to question B. Question B is telling us to find the inverse function of x, of f of x, sorry. So we're finding the inverse function of f of x is equal to x minus 3 over 4. Now, if you remember the concepts or the steps that I gave you when we are talking about inverse functions, I say the first step you do when finding the inverse of a function is that you replace f of x with the y. So we're going to replace f of x with y. So we put y there is equal to x minus 3 over 4. This is step 1 of concept 1.0, which is inverse function. Then step 2, I said you make x a subject of the formula. So here, what we'll do is, since there's a fraction here, this is also the same as 1, so you cross multiply. You say y multiplied by the denominator here, 4 is equal to 1 multiplied by x, you have x, 1 multiplied by negative 3, you have negative 3 there. So this is 4y is equal to x minus 3. Now by making x a subject of the formula, we have to remove this negative 3 this side so that it comes here, x should remain alone. That means we have made x a subject of the formula. So what do? You can either introduce both sides, you introduce positive 3 both sides, or what you do is, let's go the easiest way. When you are dealing with such numbers, you get the number together with a sign in front of it. That's negative 3. So you get negative 3, you take it to this side. So it will become 4y. When this negative number crosses an equal sign, it becomes a positive value. So you have that there and that. So this means that we have made x a subject of the formula. So this is step 2 of the concept. We have made x a subject of the formula. So from here, I'm going to write on top there to continue my calculation or my solving. So we have 4y plus 3 is equal to x. Now, step 3 of the concept says that you replace or you exchange the position of x and y. So where there is y, you write x, and where there is x, you write y. So you have 4x plus 3 is equal to y. Step 3 achieved. Now, step 4, or the final step, you are replace y with f negative 1 of x. So I'm going to have, I'll write it like this. I'll start with f of negative 1 of x is equal to 4x plus 3. With that done, that means you have finished, you have actually come up with the inverse of this function there that you have been given. So the first step is replacing f of x with y. Second step, making x a subject of the formula, which we did here. Then, after making x a subject of the formula, exchange places. We move where there is y. This one comes here. Where there is y, you bring in x. Where there is x, you bring in y. You get to have that there. After that, we replace this with the f inverse of x, as done in the final step there. So right now we're going to now look at question C, which is saying f of g of x. So remember, when we're talking about the concepts, one of the concept 1.1, or the second concept of this video was composite functions. So when you just see functions have been written like this, it means a composite function. So what does it mean? What I'm just trying to say here that x in f of x is equal to g of x. Where is x in f of x, we're going to put g of x. But what is g of x? G of x is actually 2x plus 1. So where there is x here in f of x, we're going to put 2x plus 1. So our f of x is x minus 3 over 4. Then fg of x is going to be 2x. Where is x here? We're putting 2x plus 1 minus 3 over 4. Then fg of x will be 2x positive 1 minus 3. We're going to have minus 2. Since the signs are different, positive and negative there, you subtract, then the sign will come from a bigger number, over 4 there. Then you have fg of x is equal to 2. Here we can just factorize 2 on top there, it's common. So you have 2 open bracket. Now when you're factorizing 2x there is the same as, since we have to divide it with this, you're going to have x. Then minus 2 divided by 2, you have minus 1. So we're going to have minus 1 there over 4. Then 2 is common there. You can say 2 there, 1. Then 2 there, 2. Like that. So you have that as the composite function. So how do you know which one to replace? The one to replace, you are replacing the second function, the second given function into the first given function. So check for the name. The name here is f. So you look for f of x. In f of x, you are replacing the second function there. Then you solve your composite function in a normal way like we have done there. So now we're going to look at question D, which says fg of negative 3. But now, if you look at this question, you realize that we have fg here. So this tells us that it's a composite function. So if question C didn't ask us to find fg of x. We are going to first find fg of x, because in the question here we don't have fg of x, but question C helped us to find fg of x. So we had found fg of x to be x minus 1 over 2. We had found fg of x to be that. So this is just telling us that x in fg of x is equal to -3. So while there is x in fg of x, I'm going to put -3. So you have fg of x is equal to -3 minus 1 over 2. Fg of x is equal to -3 minus 1, that's -4 over 2. Fg of x is going to be -2 there. So let me write it down here. Fg of x, fg of -3 is going to be -2. We're supposed to have fg of -3 here as well. -3, since we have replaced x with -3. So we first look at fg of x. Do we have fg of x? If we didn't have fg of x, we solve for it. Then while there is x in that fg of x, you put -3. But we didn't solve for it because we have already found it in question. Okay, so now we are done with example 1. Let's go and do our last example of this video. So our example is saying a function of f is defined by f of x is equal to 2x minus 5. Find A, f inverse of x, B, f of f inverse of 2, C, the value of x if f of x is equal to x. So A is asking us to find f inverse of x. So we have f of x as 2x minus 5. The first step in finding the inverse of a function, I said you replace f of x with y. You replace f of x with y. So where there's f of x, we'll write y. Then the second step, we said to make x the subject of a formula. So you need to remove 2 and -5 here so that x should remain alone. So we'll start with -5. You carry it together. I've said in the first example that when you're carrying a number, excuse me, when you're taking a number from one equal side or from the other side of the equal sign, you carry it together with the sign in front of it. So we are carrying -5 here. When you carry -5, you take it this side, it will be +5. It changes the sign. Then you have 2x there. So we are multiplying here. For us to remove this negative, for us to remove this 2 here and leave x alone, we need to divide both sides by 2, because it's an equation. You divide both sides by 2. So we have y plus 5 divided by 2 is equal to 2x divided by 2. This and that will go. So I'll write it like this. I'll flip it. I'll have x is equal to y plus 5 over 2. Then the third step that you have to do when you're writing the inverse of a function is that you replace y with x. You exchange y with x. While there is y, you put x, and while there is x, you put y. So we mean this should go this side. This one should come here. You have y is equal to x plus 5 over 2. Then the final step in finding the inverse of a function, when you have done that, you just replace y with f inverse of x is equal to x plus 5 over 2. With that done, that means you have solved. You have found the f inverse of x for the function f of x is equal to 2x minus 5. Okay, so now question B is asking us to find f of f inverse of 2. Now, if you go back on question A, you realize that we found f inverse of x. And f inverse of x was actually x plus 5 over 2. X plus 5 over 2. Now, this is a composite function. It's telling us that where there is x in f of x, we put what is x what is x in f of f inverse of x, we put 2. Now you realize that in the first example we didn't find what this composite function is, f of f inverse of x. We didn't find this composite function, so we need to first look for f of f inverse of x. So f of f inverse of x means that x, we put x where we put x it means that f of negative x should be put or should be replaced with x in f of x. In other words, x in f of x is equal to f inverse of x. So that's the first thing we need to find. We need to find f of f inverse of x because we don't have this f of f inverse of x. We just have f of x and we have f inverse of x, but we don't have the composite function of the two. So f of x of inverse of x is equal to, we know that f of x is equal to 2x minus 5. So we're going to have f of f inverse of x is equal to, while this x here, we put that 2 open bracket x plus 5 over 2 minus 5 there, like that. So we have f inverse of x is equal to this 2, since this is multiplication here, when you have brackets in here, it means multiplication. So this 2 can just cancel with this one at the bottom there, and you have x plus 5 minus 5. Then f of f inverse of x is equal to x, because 5 positive 5 minus 5 is actually 0. So we have that there. Now they are saying f of f inverse of 2. That's what we are finding. So it means f of f inverse of 2 means that x in f of f inverse of x is equal to 2. Therefore, since x is equal to 2 in here, f inverse of negative f of x inverse of 2 is actually 2 itself, because x is equal to 2. So we first started by finding f of f inverse of x because we didn't have it. We didn't find it anywhere. So after finding f of f inverse of x, we now replace x we now replace 2 for x in this f of f. So let's look at the final question in our example. It's telling us to find if f of x is equal to x. So we know that f of x is equal to 2x minus 5. If you look at this is a composite function. It's a composite function. So it means that f of x, what we're trying to say that x is equal to f of x in f of x. That's what they mean. So where there is x here in this f of x, we are going to put f of x. So f of x there is equal to, f of x itself is 2x minus 5. So where there is x here, when finding f of x, we are going to put 2 open bracket here, since x is here, we're going to put 2x minus 5 minus 5. So f of x is going to be, and I've said when you have brackets like that, it's multiplication. So 2 multiplied by 2x, we have 4x. 2 multiplied by negative 5, you have negative 10. Then you have negative 5 there. Then f of x is equal to 4x minus 10 minus 5. The signs are the same. What do? You add and you maintain the same sign here. 10 plus 5, 15, then you maintain the same negative. When the signs are the same there, you look at the sign in front of the numbers before you add negative and negative, you add and you maintain the same sign there. That's f of x. Now, we're not finding f of x, we're finding f of x. So they are saying f of x is actually equal to x. So in here, where we have f of x is equal to 4x minus 15, we're going to replace this with x. We have x is equal to 4x minus 15. So what do? We take this positive x, we bring it this side. So it will be x. There's a positive here. So when a positive number crosses the equal sign, it becomes negative. So we have that is equal to negative 15. Then you have we have x minus 4x. That's negative 3x. The sign will come from the bigger number like that. Then you have negative 15. Then you have negative 3x over negative 3 is equal to negative 15 over negative 3. You are making x a subject of formula. This and that goes. Therefore, x is equal to negative 15 divided by negative 3. It's positive 5. Negative divided by negative, it becomes positive. So, with that said, we have finished our examples. Side period with tutorials on. Make sure to comment, suggest the topics that you want us to do for you, share, as well as like, and turn on the notification button so that every time when we upload the new video, you should just be the first person to receive the notification. Thank you.